What's up, guys? I'm sitting here in my 1999 Jeep Cherokee. This is one of my favorite hobbies. I love working on this Jeep. And this semester for my software engineering class, I got to pick whatever project I wanted to work on. So of course, I picked something related to my Jeep. We're gonna work on a digital dashboard. So the existing dash in my Jeep is pretty dated, and you can see it's got a very 90s aesthetic to it, and it's really not that different even from the dash that these Jeeps launched with in the late 80s. I always think retro mods are really cool when you stick modern technology in an older vehicle or an older thing, and just kind of retrofit it. And so that's part of my goal for this. You can see there's a lot of important diagnostics in the dash. Obviously, we need those things to be functional, but my big idea would be to eventually be able to remove the entire speedometer and plug in a new one that I've designed as a replacement. Now, I'm not going to be able to jump in and do that right away because I don't know anything about interfacing with the factory ECU. So what I've decided is my best course of action to start with is communicating over the OBD2 port, which is the onboard diagnostics that were required on every vehicle post 1996. OBD2 seems like a good place to start because there were some tutorials online. People obviously make a lot of different apps as OBD2 scanners, and you know that it can output, the speedometer and the tach, and you can get actually way more data even sometimes than what's available on the speedometer. But getting started with this project, I really wasn't sure what would be available over the OBD2 port. So the first thing that I did is I ordered one of these little ELM327 chips, and ELM327 is like a microchip that's designed to interface with the OBD2 ports. Most OBD scanners use ELM327 unless they're like a really high-end one. They will use something proprietary, but these are really cheap knockoffs that you can get on Amazon, and I think I paid about $8 for this one, and that was the first one that I got. I ended up switching to a USB one in the end instead of the Bluetooth one, and the USB one was ironically a little bit more expensive than the Bluetooth one, which I thought was kind of goofy. But so the first thing that I did when I was getting started, because I had no idea where to start, I figured that I'd like to have it running on a Raspberry Pi because just having it on like a Linux system would be really useful. I'd have access to a whole lot of libraries. And if I wanted to scale up in the future, I can build a more competent, computer to install in there than a Raspberry Pi and still have it be running something really similar with like Debian and not have to worry about it losing any compatibility if I outgrow the Raspberry Pi, which this semester I have not. The Raspberry Pi was able to do everything I wanted it to do. So in addition to getting the OBD connectors, I also got this little display for a Raspberry Pi here. And it's a little touchscreen 3.5-inch display. It's got really nice pixel density. I just ordered this on Amazon, and I was really happy with how that turned out. So this obviously isn't a snap-in replacement for the existing dash, but the wide bar style displays that I want are like $300. And so I wanted to make sure that I had something that was working before I ordered that screen. And so I have not gotten one of those yet. Hopefully in the future, that's where this project is leading, but it's not where I made it to this semester. So getting started with OBD and learning those protocols, I downloaded a program called USB Serial Terminal on Windows. And using that program, I was actually able to send commands to the ELM327 chip and have it reply with the data from my Jeep's computer, which was really cool. I was able to sit in my basement while my Jeep was running in the garage and communicate over the Bluetooth, and that was working pretty well. Turned out that the Bluetooth was rather finicky. It would disconnect after a few minutes. And after a few weeks of playing with it and writing different Python scripts that could read it and print stuff out, this thing broke. and it started just replying with whatever command I sent it. So if I sent it like an ATX command, it would just reply like ATX and just echo the command. So I'm not sure what happened there, and I have no idea how I would reflash this or anything. So that was when I got the USB one, and it hasn't given me any trouble. So like I said, I started off with some Python scripts to be able to send commands to the ELM327 to inquire of the Jeep ECU about the data, and then the Jeep ECU replies to the ELM327, and then the ELM327 transfers that to whatever the host is, whether that's the Raspberry Pi or my PC. This process, as you can imagine, is a little bit latent. It takes quite a bit of time for the three things to bounce back and forth, especially the Jeep ECU. I think that's maybe the slowest part. It's hard to say whether it's the ELM chip or the Jeep itself that's slow, but somewhere in that send the command and wait for a reply, there's a pretty significant delay. I was only ever able to get it to give me probably four to six updates per second. And that was when I was only looking at one command. The thing that I didn't realize when I first started is that I kind of thought that the OBD2 port was just like constantly broadcasting all of that information, and that if you plugged into it, you could just translate whatever of it you wanted to. Now that I think about it, that didn't really make sense, but that was what I thought going into it. Now I realize in order to get any of that information, you have to send it a request. You send it the request, and then it replies with that information. So once I realized that, if you're trying to build a whole speedometer or a dashboard that's using a whole bunch of OBD2 information, it's going to have to be inquiring a ton of constantly requesting from the Jeep computer, and hopefully it replies fast enough to look good on the display. And spoiler alert, I'm not particularly happy with that. So I'm going to try to do something better in the future. So this is the documentation for Python OBD. So I imported this library and into my Python scripts, and then I was able to pretty quickly and easily start printing out the data from the engine on the display once I had the display for the Raspberry Pi. And then at that point, it was just a matter of beginning to put the GUI together. And I did quite a bit of research trying to decide what language I wanted to use. Since I'd already found this Python library that I really liked, I decided to do a user interface in Python and use PyQt. Qt is a C++ GUI framework, and PyQt is really just a Python wrapper around it. So everything that you can normally do with Qt, you can do in PyQt if you can figure out how to translate and interpret the commands from C++. The better solution than the OBD2 port would be to remove the speedometer and take the electrical pinouts that go to the speedometer from the ECU and connect those pins to a node that can interpret those voltages and then feed those values to the Raspberry Pi, and then the Raspberry Pi can interpret them into whatever they're supposed to mean. Because generally, if you turn on your headlights, it turns on voltage to one of those lights, one of the light bulbs in that speedometer. And so if you just had that light up that pin, then you could, turn it on digitally the same way that it would light up an actual light bulb. So in the long run, that's what I would really like this system to be able to do. So I tried to design the software around being able to do that in the long run. However, since this isn't an electrical engineering course, I didn't want to spend all my time trying to figure out how to wire that up. So I'm just using the OBD2 data for now to make it functional, with the idea of it being abstracted enough that I could easily, once I had the node system wired up, I could receive a different style of input and still use the same GUI. I'm really glad that I found that Python OBD library because it made it very simple and I didn't have to waste too much time on, I guess, interfacing with the ELM327 chip, since in the long term, the OBD port isn't really how I want to do this. So if you look in my code, all of the code that communicates over OBD is actually just right here. And this part is very simple. It's like, 20 or 30 lines. And essentially you have the commands from the OBD library to pull the specific things that you want. Then you name a connection to the OBD ELM327, and then you can just use, this is their asynchronous library where you just watch that, that command, and when it gets a new reply, it calls this function. And so that's how I paired up these 4 things. And ultimately, those are the only 4 things that I've used in this prototype. I'm sorry it's taken so long to get through the beginning part of this. Obviously, I had to do a whole bunch of research in the beginning in order to figure out all of these technologies and even just come up with a plan of how I wanted to do it. But now we finally get into the meat of the software that I created, which is this graphical user interface. So to get started, I had found an image that I thought was a good inspiration for what I just wanted the overall vibe of the speedometer to be, this Ford Bronco concept image. And so I found a similar picture that was free to use, and I started working my way toward the design that I wanted. And these are just drawings that I did. They're not anything in code per se, but essentially I wanted to have, the speed front and center, the tach over here, the coolant temperature, clock, the fuel gauge, oil pressure, and then these indicator lights. I wanted to be able to switch it back and forth from like a night mode and day mode, and then probably have access to some settings over here to be able to adjust for your speedometer for different tire sizes, and to be able to read your engine codes, any diagnostic trouble codes. And then this is the night mode image that I picked, and just drawing out what that one was going to look like. So then I took this, and from there I started laying out what that would actually look like in code. So this is the Qt Designer, which is a little GUI that you can use to kind of create your interfaces. In the end, I decided not to use the output of this, but I kind of used it to lay out what I wanted the app to look like and to figure out exactly what kind of widgets and stuff I had access to. And so it ended up being really nice, because then I had like a printed out list of, here are some different things that you can do to, a label, and here are some things you can do to a button, and it gave me an idea of how I wanted to put it in the code. So essentially I created a grid, and then I created 3 vertical layouts, and then I put horizontal layouts within the vertical layouts, and then I put the items in there that I wanted to. And this is meant to be the settings dialog. So from there, it just became the very tedious process of going through and individually setting each of these things. So you set the background image and the window size. You go through and create all of the labels. So there's where the airbag's going, there's where all the warnings are going, the clock, and just setting up all of these variables and their current types and their alignment and the margins on all of them. And that really was the most time-consuming part, was troubleshooting all of that and trying to make it look good in the end. I chose to use a QSS style sheet, which is kind of like CSS that they use for Qt. Here I'm using PyCharm, and it worked out really nice because I'm actually able to run natively on Windows the Python app that I've created here. Even though it doesn't connect to the vehicle, I can still run it and show you what it looks like. And so for the development of it, here's an animation that I put at the beginning as a splash screen. I'll show you in the code where that's at. But basically, when I was troubleshooting it and aligning everything, I could open it up here and tweak it a little and run it, and then close it and then tweak it and then run it. And you can see the clock's actually right. It's the same as my system clock because it borrows this from the system. The night mode button successfully works here. And then since I want to be receiving input to light up those lights, but I don't have that part wired yet, I just used key presses to I guess trigger those. So you can trigger the turn signals, You can also do, there's the battery indicator, the check engine light, and the check engine light does come up if there's a diagnostic trouble code, like that's an active indicator. The airbag light, that would require more stuff that I don't have wired up yet. There's the headlights and the brights. And if you're running this code, I have it set up so escape just closes it. I just kind of hard coded it to be a window the size of the display that I got, since I was using that little display, and I didn't really intend for this software to be used on multiple different devices. Ideally, I'll kind of extrapolate it into a full-size display once I get to that point. My settings screen I haven't fully implemented yet, so it has a save and close button, but it doesn't actually include the settings that I wanted. I have that laid out here the way that I intended to implement it, where it's got a slider that you can adjust the multiplier for speedometer correction, like if you've got a different tire size, and then viewing the diagnostic trouble codes. And all of that stuff is ready to go. I just ran out of time to get it all implemented. And so I was basically going to take this. One of the interesting things about this here is you can go view code, and then it pulls up code for the thing that you've drawn. So you could just kind of implement this, and that's how what you're intended to do, is leave this alone and then inherit it and then tweak it from there. I didn't like that process. It was easier for me to just kind of translate it into what I wanted it to be. But this is all in C++, if you notice, so you definitely can't copy and paste it if you want it to run in PyQt. But yeah, so essentially it's just one main window that gets initialized and then has a whole bunch of widgets inside of it that are, changing depending on specific circumstances. These are all the key press events so that I could trigger all of those lights. So these would switch in the future from being key press events to being active node events once I figure out how to hook up a node to the Raspberry Pi so that it can receive the inputs, the electrical inputs from the Jeep, and the key release events so that those things go off when you release the button. Switching day and night, this is just toggling between day and night mode, using a Boolean and the two images that I wanted to use as backgrounds. Updating the clock, like I said before, that borrows from the system clock and works pretty well. And then these are the callback methods that you get once the ELM327 says that it has new information on the RPMs. It rewrites the text for that. It does that for the speed and the coolant temperature and the check engine light status. And then here's the dialog box for settings and the splash screen for the movie, or the animation rather, at the beginning. And then down here is kind of the main method of how things run in order. I was trying to play with the order of these a little bit to try to optimize so that the splash screen stayed up for like the perfect amount of time, and then the program was ready to go. So I've got it running pretty well right now. So it does the animation, and then hopefully around that time, that's when it logs the data. So from here, I will switch to the real life view so you can see what it actually looks like.